So in this video, we're going to learn the concept of decimal representation of rational numbers. That is, in this video, we're going to learn how to express any rational number as a decimal. So to explain this concept, let me take a few examples. Let's say I want to express the rational number 1/4 as a decimal number, right? So how do we do it? See, whenever you want to express any rational number as a decimal, simply divide the numerator by the denominator. So what is the numerator over here? 1. What is the denominator? 4. So simply divide 1/4 by the long division method. So we have 1 divided by 4, right? Now in general, put a decimal over here. So decimal over here, copy your decimal over here and put at least 2 zeros. I repeat, numerator divide by the denominator, put a decimal over here and by default put 2 zeros. Now let's begin the division process. How many times does 4 go in 1? It goes there 0 times. So write a 0 over here minus 0. 1 minus 0 is 1. Bring down the next digit. How many times does 4 go in 10? It goes there 2 times. So above the 0 put a 2. 2 multiplied by 4 is 8. 10 minus 8 is 2. Bring down the next digit. How many times does 4 go in 20? 5 times. So above the 0 put a 5. 5 multiplied by 4 is 20. 20 minus 20 is 0. So we have got the remainder 0. That means we have to stop over here. I repeat, whenever we get the remainder as 0, we stop over here. So what is the answer? 0.25. So 1/4 is equal to 0.25. Right? So we have expressed a rational number as a decimal. Right? So how do we express a rational number as a decimal? Simple. Divide the numerator by the denominator. Right? Let me take another example. Let's say we want to express 7/8 as a decimal. Right? So what do? Divide the numerator by the denominator. What is the numerator? 7. What is the denominator? 8. So we have 7 divided by 8. Right? So like I told you, put a decimal over here, copy your decimal over here and put minimum 2 zeros. Now let's begin. 8 goes into 7 how many times? 0 times. So 0 multiplied by 8 is 0. 7 minus 0 is 7. Bring down the next digit. 8 goes into 70 how many times? 8 times. 8 multiplied by 8 is 64. 70 minus 64 is 8. Bring down the next digit. Now 70 minus 64 is 6. Bring down the next digit. 8 goes into 60 how many times? It goes there 7 times. So 7 multiplied by 8 is 56. 60 minus 56 is 4. Now here the remainder is not 0, so add a 0 over here. I repeat, because the remainder is not 0, add a 0 over here. So bring down the next digit. 8 goes into 40 how many times? 5 times. 5 multiplied by 80, 40. 40 minus 40, 0. Remainder is 0, so we stop over here. So 7/8 is equal to 0.875. Right? So this is how you express a rational number as a decimal. I repeat, it is very simple. Simply divide the numerator by the denominator using long division method. You will get your answer. So 1/4 is 0.25 and 7/8 is 0.875. Right? So I hope it is clear till now. Now if you notice, in both these examples, we got the remainder as 0. I repeat, in both these examples, we got the remainder as 0. Now this may not always be the case. Right? So let me show you an example in which we'll never get the remainder as 0. So let me take a very simple example. Let's say I take 1/3. Right? So we want to express 1/3 as a rational number. So what do? Like I told you, divide the numerator by the denominator. So this is 1 divided by 3. So let's divide 1/3. So like I told you, put a decimal over here, copy your decimal and put minimum 2 zeros. Right? Let's begin. 3 goes into 1 how many times? 0 times. 0 into 3 is 0. 1 minus 0 is 1. Next, bring down the next digit. That is 0. 3 goes into 10 how many times? 3 times. 3 multiplied by 3 is 9. What is 10 minus 9? Again it is 1. Right? Bring down the next digit. 3 goes into 10 how many times? 3 times. 3 multiplied by 3 is 9. 10 minus 9 is 1. Now is the remainder 0? No. So let's add another 0. Bring down the next digit. 3 goes into 10 how many times? It goes there 3 times. 3 into 3, 9. 10 minus 9 is 1. Still the remainder is not 0. So let's add one more 0. So I'll put another 0 over here. Bring down the next digit. 3 goes into 10 how many times? 3 times. 3 into 3, 9. 10 minus 9, 1. Right? Now let's stop over here and let's analyze what is happening. See, every time we're getting the remainder as 1. 1, 1, 1, 1, 1. Right? As a result of which, again and again we're dividing by 10. So what is happening in this case? What is happening in this case is that remainder is getting repeated. I repeat, see over here I've written in blue. See, the remainder 1 is getting repeated again and again and again. So because of that, we are again and again doing the same thing. 10 divided by 3, 10 divided by 3, 10 divided by 3, 10 divided by 3 and so on. Right? So in such a case, you will not get the remainder as 0. That is, no matter how long you go, you will not get the remainder as 0. So what is 1 by 3? It is 0.333333 infinitely. I repeat, what is 1/3 as a decimal? It is 0.33333 and so on. Right? So whenever you express a rational number as a decimal, there are two things. Either the remainder will be 0 or the remainder will not be 0. I repeat, whenever you express any rational number as a decimal, two things may happen. Either the remainder will be 0 or the remainder will not be 0. In case the remainder is not 0, like over here, the remainder will start repeating itself. Like over here, remainder is repeating itself. Also over here, the digit starts repeating. Right? So whenever the remainder is not 0, here the remainder will start repeating and here the digits will start repeating. Right? So what are such type of rational numbers called? See, over here remainder is 0. Whenever the remainder is 0, that means division is finished. I repeat, whenever the remainder is 0, division is finished. Another word for finished is terminates. Right? I repeat, another word for finish is terminate. So because division finishes over here or division terminates, hence such decimals are called terminating decimals. I repeat, what does the word terminate means? To finish. So whenever the remainder is 0, division is finished or division is terminated, hence such decimals are called terminating decimals. That is, what do we get if we extend this division? If we extend this division, 4 goes into 0 how many times? 0. So we'll get only zeros after this. Only zeros after this. So such decimal numbers are called terminating decimals. So what are such numbers called? Here, is the division getting over? No. Is the division terminating? No. So these are non-terminating decimals. Terminating, these are not terminating, hence they are non-terminating. So such type of decimals are non-terminating. Right? Now, if you notice over here, the digits are repeating themselves. Right? So another word for repeating is recurring. I repeat, see here in the quotient, the digits are repeating themselves, right? Or we can say the remainders are repeating itself. So because the digits are repeating, another word for repeating is recurring, coming again and again. Hence they're called non-terminating recurring decimals. I repeat, what does the word non-terminating means? Division is not getting over. Recurring means the digits are repeating themselves. So such decimals are called non-terminating recurring decimals, right? So whenever you express any rational number as a decimal, either you'll get a terminating decimal or you'll get a non-terminating recurring decimal. I repeat, whenever you express any rational number as a decimal, you'll either get a terminating decimal or you'll get a non-terminating recurring decimal, right? That means if I give you any rational number and I ask you, please express this as a decimal. So till what point will you divide? You will continue your division till either you get the remainder as 0 or the remainder begins to repeat itself. I repeat, you will continue the long division till either you get the remainder as 0, like over here, or the digits starts repeating themselves over here. That is, the remainder start repeating and the digits start repeating, right? So I repeat once again, let me do a recap. How do we express any rational number as a decimal? Simple, divide the numerator by the denominator. Now when you divide the numerator by the denominator in the division, two things may happen. Either you'll get the remainder as 0 or remainders will begin to repeat themselves, hence digits over here will also repeat, right? So such type of decimals are called terminating decimals. Terminating means finished. See, once the remainder is 0, division is over, it is finished, hence terminating decimals. Over here division will go on and on and on, hence non-terminating because digits are repeating, hence recurring. Recurring means to come again and again. So division is not getting over, hence non-terminating. Digits are repeating, hence recurring. So these are non-terminating recurring decimals and these are terminating decimals, right? So till what point will you continue division? Till either you get the remainder as 0 or digits begin to repeat themselves, that is remainders begins to repeat themselves, right? Now, we have expressed these rational numbers as a decimal. How do we express this as a decimal? Simple. How we write it as this is equal to 0.3. Now the digit 3 is repeating itself, hence over 3 we put a bar. I repeat, how do we represent this? See, 3 is going on and on and on. So what you do is write your quotient. Whichever digit or more digits are repeating themselves, put a bar over them. So here only one digit is repeating, that is the digit 3. So we put a bar over 3. So whenever you see such type of decimal number where there's a bar over this, that means this digit is repeating itself, right? So this is the concept of decimal representation of rational numbers. How do we represent any rational number as a decimal? Simply divide the numerator by the denominator. Either the remainder will come at 0 or the remainders will repeat themselves and digits will repeat over here. Such numbers are called terminating decimals. Terminating means getting over. So because division is getting over, hence terminating. Here division goes on, hence non-terminating. Digits and remainders repeat itself, hence recurring. So you'll either get a terminating decimal or you'll get a non-terminating recurring decimal, right? So let me take a few more examples of this type so we become absolutely clear on this, right? So this is the basic concept of decimal representation of rational numbers.